Good afternoon, everybody. I'm Stephanie Santel with EPA's Office of Water, and I'll be moderating today's webcast along with Ikra Nasser. Thank you all for joining us today. We'll start by going over a few housekeeping items. To briefly cover some features of today's webcast, if you have any technical issues or have a question for the presenters, let us know by typing in the questions box on your control panel. If your control panel is not showing, simply click on the small orange box with the white arrow to expand it above. We'll try to answer as many questions as possible after each state presentation and at the end as time permits, but due to the high number of participants, we may not be able to answer all the questions submitted, so please do follow up with the appropriate speaker after the webcast. Now let me introduce our panel of highly esteemed speakers. Today we will hear from Aaron Borisenko from Oregon Department of Environmental Quality and Rebecca Hillwig from Oregon Health Authority, from Maryland Department of Natural Resources, Kelly Collins-Choi and Nicole Carlozzo, and Carrie Banks from Massachusetts Department of Fish and Game. Please note the materials in this webcast have been reviewed by EPA staff. However, the views of the speakers and the speakers' organizations are their own and do not necessarily reflect those of EPA. Mention of commercial enterprises, products, or publications does not mean that EPA endorses them. A very special thanks to all of our speakers for sharing their work with us today. So today's webinar will start with an umbrella presentation by myself, sharing how the partners work together to identify the state practices and develop the case studies. State presentations will follow, each focusing on their practice that was highlighted in one of the case studies to date, and the state panelists will present starting with Oregon, Maryland, and then finally Massachusetts, and a questions and answers session with the participants will follow at the end. Ikra Nasser will be moderating the questions throughout, and with that, we'll begin our presentation. So first and foremost, thank you for allowing us to share our project with you today, and many, many thanks to our state association partners that help make this project possible. Today you will hear about how practices in Oregon, Maryland, and Massachusetts water resource programs are working to build resilience. But before that, I'm going to provide you with an overall background of the project that's helping to identify and collect these types of initiatives. I'm happy to take questions after the presentation at the very end, or you can of course reach me by email or phone at the contact information provided. So it's evident there are a lot of resiliency-focused efforts occurring at the federal and regional level, but many state and even local communities also have a lot of work going on. And what we've learned through developing the project is that state agencies differ in their approaches for addressing water resource concerns for a variety of different reasons. It could be due to programmatic priorities, regulatory processes, financial and technical capacities, and even access to data and information to support their decision making. And what we've seen is that while many state agencies are taking action to address climate, drought, extreme weather, sea level rise, or other novel impacts to water resources directly, others are pursuing alternative efforts that incorporate variability and resiliency considerations within their existing programmatic frameworks. So why develop case studies? Well, over time, water resource managers have and are going to continue to face new environmental stressors that really challenge the way we do business and thus force us to evolve in order to maintain the effectiveness of our water resource programs. By developing these case studies, we can take those lessons learned and those success stories from other locations and continue to build on the work that's already started, especially when there are resource constraints. Why not learn from leveraging each other's knowledge and lessons learned? So that's exactly what this project does. It captures those stories to share them widely with others. It's hard to believe that we started this project back in 2015 and have 2 phases of case study development completed to date. And it's really been a nice collaboration between partners that are listed on this slide that you see: Association of Clean Water Administrators, Association of State Drinking Water Administrators, and Association of State Wetland Managers. And all of the partners are committed to highlighting work performed by the states and maintaining a state-centric focus for the project. So the goals of the project are really twofold. The first is not only to increase the general understanding of what the key issues are and the work being done to address them, but also the hope that showcasing a diverse array of adaptation or resiliency practices in several program areas and locations around the country may help inspire replication of those effective or tested models across a broad audience. And when I say a broad audience, I mean not only across and between state agencies, but to other local and tribal organizations as well who are interested in this kind of work. So really focusing in on that tech transferability. So this slide outlines our general process during which we have a high degree of interaction with several state agency staff, association staff, and the EPA program offices. You should know that this project was built from the ground up, all in-house, from the PDF that you can hold in your hand and print out on the web page to the actual web pages themselves. So when we conceptualized the project back in 2015, we finalized a work plan with input from Office of Water program staff, as well as the state association partners. And that work plan included a set of selection criteria, which were drafted to help more objectively determine which state agency examples to include in our final compilation. We then compiled a list of candidates from which to select those final state practices to showcase. So a total of about 50 to 60 candidates were identified per phase from surveys, reports, and recommendations by the state associations, as well as other state sources describing progress on adaptation or resiliency that are available to the public and really were found online. From there, we went on to summarize some findings for that broad list of candidates by performing some basic stats, which demonstrated that we were achieving that programmatic and geographic diversity that we were looking for. We selected 10 to 15 state practices for further development and drafted descriptions from there, and then got in touch with the appropriate state contacts to gather more information on the practice, ensure the accuracy of that information that we had, and to revise the narrative descriptions over time. And then for the final step in the process, the state associations really worked hard to obtain state agency senior management endorsement of those practice descriptions and a final sign-off for release. So just to note, for this second phase, 9 of the 10 practices have been finalized to date, and 8 of those are currently available on our webpage if you visit it. And as I mentioned earlier, the project identifies progress made in various water program areas, both under the Clean Water Act and Safe Drinking Water Act, and we do try to keep a balance of human health and ecosystem-related initiatives in that mix. So this is just a very cursory list for you. If you move on to the next slide, it'll give you a glimpse of how the practices actually appear in the database. So next to each state practice title, you'll find keyword tags for specific topic areas covered within each of the narratives, and we hoped this feature would help match the most relevant audience to a given practice. So if you keep scrolling down the page and you click on one of the states, it'll open up a PDF document that looks very similar to this. And you'll notice that every practice is about 2 to 3 pages long, no more, and has an overview section, a background section capturing key events or issues that predated the state action, and a list of state practice partners, state agency contacts, and initiation date in that upper right-hand blue shaded box. So yes, you can contact a real person to talk about this information with, which is a great feature. And throughout the text, we also have embedded links that you can see under the overview that are highlighted in blue. So if you want more information on those specific details, it's easy for the reader to obtain that. And then, as you can imagine, there are many benefits of doing this project, but perhaps the most obvious one is the broad scope. So the current compilation focuses on practices from different state agencies that highlight innovative and effective adaptation or resiliency actions or planning efforts across the entire country. In many ways, the project provides a means to engage with our state partners and form lasting collaborative partnerships, which is very important. And so we can help form those partnerships also across states and other organizations. And finally, building upon the practices in the database, we'll continue to highlight the leadership of our state agencies, not only as the implementers of our national programs, but as key innovators that really are doing a lot of work to advance water resource program activities across the country. And as a separate note, many of our state partners have also used their write-ups as a communications handout. So aside from getting to broadly communicate their work and having it up on the web page, they do get a useful product to have in hand at the end. To date, we've pursued several approaches for sharing the practices through social media platforms, newsletters, and stakeholder meetings. But now that a fair amount of state practices are available on the web page, we are taking next steps for broader and bigger efforts to both circulate the information and hopefully inspire other states to share their work through this project. This webinar, of course, is one of them, and we had an earlier Association of State Wetland Managers webinar, which was held at the end of February to feature our wetland-specific practices to date. And just a note about this picture that I have, you'll see that this young gentleman has a water droplet on his hand with California's abbreviation, and this picture actually hails from one of our write-ups that we have on the web page about the California Save Our Water program, which is aimed at helping residents reduce everyday water use by sharing conservation ideas and tips. And it's a great reminder and a really nice write-up of how we can reach people and make them excited about getting involved. So if selfies are a part of that equation, I could say the sky is the limit on that one. And then finally, I'm just going to end with reiterating the benefits of continuing the project. Again, encouraging discussion after the initial release back in 2015, as well as adding more practices over time, can help really sustain those collaboration and communication channels for sharing work across states and with others as well. And it goes without saying that maintaining those positive relationships with our states and other organizations in the future can serve as a way to continue achieving our shared objectives for water resources in the future. So with that, please don't hesitate to reach out should you have any questions, and thanks again for the opportunity to share this work with you. Now we're excited for and appreciate the chance to share some of the specific program practices we've captured in states around the U.S. And with that, I will turn it over to Aaron and Rebecca in Oregon.
All right. Thank you, Stephanie. Well, my name is Aaron Borisenko. I work for the Oregon Department of Environmental Quality Monitoring Section here in Hillsboro, Oregon. Nice to be here today. And today I'm going to talk about Oregon's response to harmful algae bloom management and monitoring. So you should see a slide that says Presentation Overview, and I'm going to be talking about Oregon's harmful algae bloom strategy that was developed in 2011. And then I'll briefly talk about the harmful algae bloom drinking water program here in Oregon and how we respond to HABs in drinking water. Then I'll get into our general approach to surveillance monitoring of harmful algae blooms and the partnerships that involves. And then I think what you might find interesting is the specific case study of the Willamette River, a major river water body that flows from south to north right through the Willamette Valley and through downtown Portland and other major metropolitan areas, and the harmful algae bloom situations that have cropped up in the past and how we're dealing with that. And then I'll touch on lessons learned. So I want to start by just giving you an overview of Oregon. Oregon's a fairly large state, and we have blooms that crop up in different types of categories. These are some of the types of water bodies that experience blooms on a regular basis, and they fall into sort of four categories. They're reservoirs, there are river water bodies that have harmful algae blooms, coastal lakes that tend to have these blooms, and then small ponds, either urban ponds or agricultural ponds. And so this map is not to show you a comprehensive list of all the places where blooms occur, but rather the categories of blooms where they occur. You might also notice that over here in the extreme eastern part of the state, we don't seem to have any blooms, and that's not because they don't occur, but this is a very low population density. We don't get a lot of reports from this area. We know that they occur out here, but they just don't get reported. And so I'm going to start with a schematic of the harmful algae bloom strategy. And basically it all starts here on this left-hand column where you have harmful algae bloom surveillance and water monitoring. And this is sort of the data collection aspect. And the data for harmful algae blooms and reporting can come from a variety of mechanisms, whether it's through our federal partners like the Forest Service, Army Corps of Engineers, Bureau of Reclamation, public water systems. And that can involve then some data collection, which would inform whether or not an advisory is needed. And if none of these agencies are available to collect water data, then our agency, the Oregon Department of Environmental Quality, might go out and collect some information. And that can lead to an advisory. And if an advisory in Oregon is posted by Oregon Health Authority on a water body, that information is actually sufficient to use in our water quality assessment, the 303D list, to list that water body as impaired, and which will then implement some of our core water quality planning functions like TMDLs, drinking water protection strategies, watershed action plans, and whatnot. And then we can then implement through permits and non-point source load allocations actions that might help this harmful algae bloom process in the future. We also have other types of data, things that relate to pH, dissolved oxygen, and chlorophyll that we have standards for, which often relate to harmful algae blooms, and these types of data will then also lead to impairments on our list of water quality impairments, which will then lead to these actions through the Clean Water Act approach to dealing with the problems. If you want more information on that, I've posted the link below and it's available on the presentation. So characterizing the types of blooms we have, a lot of these can come from external loading factors, like in our reservoirs. Oregon is, of course, on the Pacific Ring of Fire, and we have a lot of volcanic soils which are high in phosphorus. And when you have these large reservoirs with a lot of dendritic fingers, there's a lot of surface interaction with soils, and these soils are high in phosphates, and that can really feed these blooms in the summertime when we get a lot of sunlight into creating these large blooms. We also have situations where there are introduced fish species which may preferentially feed on zooplankton, which can alter the food web and provide opportunities for phytoplankton blooms and cyanobacteria blooms in certain lakes. So we talked about the reservoir experience with harmful algae blooms. Then we get these blooms in small ponds and urban areas and agricultural areas, which may best be mitigated by control measures like aeration or dredging or alum flocculation or something of that nature. And then there's the unique experience, I think, of rivers and the challenges that rivers pose in managing when these harmful algae blooms occur. We'll talk a little bit more about that later. So as we mentioned, the programs that address these types of things in the strategy are the surveillance monitoring. And surveillance is somewhat misleading because it's not like we're out actively looking for blooms all over the state, but we're really relying on our partners, citizens, and others to report blooms that we can then make an evaluation of whether an action is necessary to protect public health. And then we talked about standards and assessment when there is an advisory posted, and the mechanisms for taking action on reducing nutrients and things that would help blooms in the future. And that goes into the TMDL water quality management planning aspect. We'll talk a little bit more about the drinking water protection process in a few slides here, and then non-point source load allocations trying to reduce the nutrient runoff in areas that have excess nutrients flowing into water bodies to try to control nutrients that exacerbate these harmful algae blooms. And then our permitting program. Those are all mechanisms that address harmful algae blooms in the long term. So some of the strategies are to restrict the available nutrients, to reduce external loading from watersheds that drain into these water bodies, internal loading, which can be things like dredging or alum flocculation or removal of invasive fish species, which can not only contribute to unfavorable trophic interactions, but actually contribute to the nutrient loading in specific lakes. Trying to maintain water movement, so quiescent stagnant waters in some cases need to have some kind of mitigation for those stagnant conditions. Reducing light availability and reducing the water temperature can all be strategies for helping to control harmful algae blooms. So the strategy at the end recommends an enhancement of the surveillance, monitoring, advisory, and education approach. Things like Bloom Watch, which have been promoted recently, might be a mechanism for doing that as long as it's done strategically, and there is a process in place for responding to those increased reports. Enhance our own department, Oregon's focus on identifying the causes that are starting harmful algae blooms in the listed waters, and expanding efforts to understand the role of invasive fish species or introduced fish species where they are causing problems with lake eutrophication, and then enhancing our department's focus on nutrient reductions. So I'll talk briefly about the drinking water program, which is implemented by the Oregon Health Authority. The Oregon Health Authority receives $15,000 a year for drinking water protection. And that money is provided to public water systems that need initial help with toxin analysis to understand if a harmful algae bloom could be impacting the source water that's coming into their systems. And so if there's a bloom that's been identified and there is source water intakes that need to be addressed, then analysis can be done for all 4 types of toxins: microcystins, cylindospermopsin, saxitoxin, and nanotoxin A, first in the raw water, and then if those toxins are present in the raw water, then an analysis of the finished water is then conducted. And the program actually facilitates the initial sampling, but then the lab that's responsible, the drinking water facility, is responsible for taking it over from there. And if there are toxins present, then weekly monitoring is done until the bloom is, we're assured that the bloom is gone. Again, the most important information here is to really know that none of these cyanotoxins are making it through to the finished water in the drinking water process. So here's how the process works. There's a public health advisory posted that might be affecting a public water supply. And if that's the case, then the test of raw water occurs weekly for associated toxins. And if those toxins are detected in the raw water, then the next step is to test the raw and the finished water weekly and optimize any treatment for toxin removal, and make sure that any downstream public water supplies are notified immediately that these toxins have been found in the source water. Finished water toxin detections above these thresholds are triggered, so microcystin above 1 microgram per liter, anatoxin at 3 micrograms per liter, and these other values here. And so if the visual signs up here of the bloom are present, then that starts the process of identification of the algae species and looking for cell counts in this range, which would also trigger this test of source water. So this is the basic process that is used by the Oregon Health Authority to work with the public water systems when a bloom has been identified upstream of source water that could be impacting public water supplies. Okay, so now I'm going to get into Oregon's general surveillance approach, how we deal with the coordination of surveillance of harmful algae blooms in Oregon, and then I'll get into a specific case study of the lower Willamette River, which I think you'll find interesting. This, incidentally, is Horse Thief Reservoir, which experienced a bloom a couple of years ago and was a case where, because of its remoteness and lack of contact with sort of public recreational issues, no advisory was posted on this water body and no samples were collected. So we can receive a call to action in a number of ways. Sometimes it'll be a citizen calling in that they've noticed something in the water that's bright green or bluish in color. It can be identified as a paint spill or something else. Or we might receive a call through the Oregon Emergency Response System, which is typically used for things like spills. So blooms can sometimes be reported as a spill of some type, and will get notified through this Oregon Emergency Response System. We have an environmental complaint submission form on our webpage that will sometimes get a call for something that's in the water through that mechanism, or just word of mouth. Somebody in our own agency or someone else sees something and calls us up to let us know. So we have a number of mechanisms by which we can be notified of a harmful algae bloom in play. And that triggers a coordinated response. So the lead agency in Oregon for harmful algae bloom response is the Oregon Health Authority. And so if anyone receives a call about a harmful algae bloom, the correct pathway is to start by contacting Rebecca Hillwig or someone at the Oregon Health Authority about developing a plan for this particular response. And if it's warranted, if it looks like it is a bloom, there is photo documentation or something that really leads us to believe that we need to take some action, then we'll follow up with doing some visual surveys, making sure that a sample has been collected, either by the reporting agency or by the responsible party for sample collection. And if no responsible party can be identified, then the Oregon Department of Environmental Quality would step in to collect that sample for analysis. Then there's this ongoing coordination and communication component on posted advisories to make sure that we're tracking the progression of the bloom, to understand if it's getting better or worse, and making sure that the media and other contacts have been notified. Okay, so risk management. Generally speaking, there's a coordination aspect where we're, like that Horse Thief Reservoir example, we need to discuss whether or not there is an imminent public health risk for that particular bloom, and that will lead us to make some decisions about whether an actual sample will be collected in that instance, or whether we feel like it's in a remote enough location that really might not pose a public health risk. And then some decision about whether we're going to collect a sample for cell count analysis or use toxin-based monitoring approach to issue that advisory. Cell count analysis is useful in a remote location because you could do a cell count analysis if you find threshold values for cyanobacteria species. Then that can be posted and left until the bloom is basically visually subsided, when then you can do a cell count and toxin-based analysis at the end of the bloom, which is a lot less costly than having to do and maintain a toxin-based approach through the life of the bloom. So here are some of the coordinating partners in Oregon. Oregon Health Authority is the lead. DEQ works closely with the Oregon Health Authority to work on harmful algae bloom issues and to make sure that we're coordinating on the monitoring aspects. The Oregon Department of Agriculture plays a role on agricultural lands, as do other state and natural resource agencies, and then there are all our federal partners here, including local government agencies and lake associations. So there is a lot of coordination involved. And one thing we've tried to develop in Oregon is a memorandum of understanding between our state agencies on how we will coordinate around harmful algae bloom response. And each of our natural resource agencies that deal with water do play an important role in this statewide issue. It's not just in one part of the state, but it's statewide. And so by developing this document that defines our roles and responsibilities and tries to make an effort to discuss how we can work together on these issues, we're starting to document a better way to do our surveillance monitoring. So now I'm going to get into a specific case study on the Willamette River here in Portland. So if you follow my cursor here up at the top, this is the Columbia River, which flows from east to west out towards the Pacific Ocean. It's about 60 to 70 miles in this direction. And then you have the Willamette River, which flows from south to north right through downtown Portland. This is the Portland area here. The river flows right through and connects to the Columbia River before it flows out to the Pacific Ocean. This little area right here, you can see this little bulge in the river is Ross Island, and this is an expanded view of Ross Island Lagoon from 1942 to 2016. Back in the earlier part of the 1900s here, Ross Island Sand and Gravel started a quarry in this area to produce gravels for concrete production for the Portland area. And in that process, they bermed off the actual natural islands to create this lagoon. And they would use the gravels coming out of this lagoon to process to create concrete. They're no longer doing that anymore. They actually, the facility still processes gravels, but those gravels come from Washington State. They're barged upstream and then processed here. So this lagoon is actually no longer actively being dredged. But what is happening here is they're doing some restoration activities in this area, and there is this deep hole here that is pretty quiescent in the summer months. And so as the flows in the Willamette River drop and the temperatures warm up, this kind of acts like a pond or a reservoir, and it does facilitate the development of blooms. Here we have Ross Island Lagoon in 2016. So we've had in 2014, 15, and 16 some big blooms on the Willamette River, and as we have made some real progress on reductions of bacteria to the point where people can safely swim in the Willamette River most of the year and not have to worry about bacterial concentrations from spills of sewage overflow, and that's been a really positive message. We're having these other issues with harmful algae bloom developments, which are spilling out into the main channel and causing sort of a challenging mixed message here. So we had a fairly substantial bloom in 2014, which impacted a lot of the activities that were planned on the Willamette River, like regattas. There was a triathlon, which included a swimming portion in the Willamette River. We had a dog sickened by the algae in the Willamette River. There's a lot of paddle boarders and a lot of use in the river in the summer months. And so this had a big impact on recreational activities and businesses. We have this early warning system, which is really helpful. So the USGS has a data sonde deployed right in the downtown reach of the Willamette River, and it has a phycocyanin probe. And while it's not located optimally to understand what might be coming out of Ross Island Lagoon, it does give us an early warning system to keep track of sort of phycocyanin concentrations. And so during the summer months, I'll routinely jump onto this website to see what's going on just with the chlorophyll and phycocyanin concentrations, and that can be a precursor to a bloom development and can kind of lead us to taking some actions in advance of this bloom really forming. Nice to have that. So in 2015, when the bloom was reported, we took a cell count approach to this. So we had folks from my staff go out in a boat and start to look at the reported bloom. And what they found was there was a bloom occurring inside of Ross Island Lagoon, and the bloom had, flowed out into the main channel and right down into downtown Portland. And so we collected samples in these areas along this channel here along the side and downstream to determine what species were present and at what levels. And we did find high values for microcystis in the main channel and values above the threshold to issue an advisory. So what we did was, working with Oregon Health Authority, there was an advisory issued. And this is the tricky part of working in a river system, is to determine sort of the extent of the advisory area. We did that by really taking a boat and exploring the area around Ross Island Lagoon, going upstream to see what we could find, traveling down right through the heart of downtown Portland and looking. And what we found was, the bloom would kind of follow the thalweg, or the main flow of the channel, and it would migrate from side to side. So we would see it present on the west side of the bank, and then maybe traveling over to the east side, and there'd be some slower pockets of water which would accumulate bloom materials. And so we basically, after doing this assessment, determined that this entire stretch, which is almost 5 miles, warranted some type of an advisory. So that's what was done. We issued an advisory from this island here, which is called Sovey Island, the southern tip, all the way up to Oaks Park, which is an amusement park here at the southern tip of the Willamette and this part. So then the process is to do ongoing visual assessments to see how the bloom is progressing. And we would go out on the river, and you can see the streaking here that's crossing the river, see the migration of the bloom downstream, to see how things were progressing and if any modifications needed to be made. And so we would get out in the water once or twice a week to do these types of visual assessments. Because it was a cell count analysis, we would also do just microcystin test strips, knowing that it's really kind of a semi-quantitative analysis, but using this as a screen to see if we're getting any toxin production, at least for this one cyanotoxin. And we take these readiness kits, and if preceding major events like regattas and floats and the triathlon, we would do a full screen for all the cyanotoxins to ensure that there was nothing that we hadn't measured that we needed to be concerned about to enhance the advisory in some way. So because of all the concerns with the area of the advisory in 2015, in 2016 when we had the bloom occur, we took a different approach. We did cyanotoxin monitoring. This requires a lot more effort because you need to be out there constantly monitoring the toxins in the water on a weekly basis to make sure that the bloom is not impacting the lower reaches. It did allow us to just keep the advisory in the Ross Island portion and not extend the advisory through this whole 5-mile stretch. And so now, as of this year, we at DEQ have got an automated cyanotoxin analyzer. We got some funding to purchase this analyzer. Unfortunately, we didn't get funding to hire an analyst to use this analyzer, so we're working through those issues right now, but we do hope to have an increased response capability in the future. And so I think the lessons learned are that the resources for cyanotoxin surveillance monitoring are limited. In fact, we really don't have any dedicated funding for cyanotoxin or surveillance monitoring. But when these things occur, especially in highly populated areas, the expectations are high that a response is mounted in short order. It's really important to know who your partners are, because when a response is needed, you really need to rely on multiple partners to get the job done. And there needs to be a strong communication network, setting up email distribution lists for specific areas, having memorandums of understanding between state agencies. Rebecca developed a really nice checklist for for the lower Willamette that we use to understand who's going to be doing what and how the coordination should occur. And then really it's important to know the history of where these harmful algae blooms occur and reoccur so that you can anticipate where these responses might be requested in the future. And then figuring out how to make sure that the communication, when there's risks involved, reach all the potentially affected communities. What languages do these advisories need to be posted in? What about the homeless populations that are sometimes using these water bodies in ways that we might not know about? So considering environmental justice communities. And then when opportunities exist, like we received some emergency funding to help with some response on the lower Willamette, we were able to purchase that cyanotoxin analyzers, taking those opportunities to build your capacity in the future. So our next steps are to continue to build these partnerships, to work to enhance our ability to respond quickly, document so that we don't reinvent the wheel and that we can pass on what we've learned to the next generation of harmful algae bloom folks, and trying to continue to seek dedicated funding for harmful algae blooms, using our core water programs to identify and control contributing factors to the blooms. And then I think we want to work on incorporating something like Bloom Watch, the crowdsourcing application, to get better reporting of blooms so we can understand the extent of the problem in the future. And so with that, I'd be happy to answer some questions.
Thank you, Aaron, for an excellent presentation. We have several questions. The first one is, how useful is remote sensing for harmful algal bloom detection?
I think it has applications. It has been used by some folks in the Army Corps of Engineers here. We don't have great model validation here in Oregon like I know some of the Great Lakes have. So I think there's more sort of primary research that needs to be done in Oregon around the utility of remote sensing, but it's definitely something to look into.
Great, thanks. Moving on to our next question, who funds the USGS sonde in the Willamette River?
Well, the USGS, I don't know actually where they get what their funding is for that particular data sonde. It is an extremely useful tool for us to be coordinated and to really understand in advance when this bloom might be forming in the Willamette River. So, I think the state very much appreciates the fact that the GS has that there. And I think it does, add that there are other locations around the state and that this type of technology would be very useful.
Okay, we have another question for you about where does the 15K for the PWSs come from, DEQ or OHA?
That comes from, that's Oregon Health Authority's funding source. And Rebecca, perhaps you could answer that question about where OHA gets that funding.
Yeah, actually it comes from the State Revolving Fund, which I'm not sure exactly if DQ actually is, if it's passed through or what, but it is a part of the State Revolving Fund monies that go like towards, sometimes it goes towards drinking water facilities, sometimes public, what is it, oh gosh, sewerages, that kind of thing.
Infrastructure.
Yeah.
Thank you both so much, and we have one more question we're going to get to before we move on. Are modeling tools available which would help identify risk of a bloom to allow you to pre-locate response resources?
Well, our TMDL modelers downtown do a lot of nutrient analysis for a variety of issues on lakes that have chlorophyll problems, dissolved oxygen problems, and that's the same of rivers and streams. I don't know that they're specific to harmful algae blooms, but I think they're related.
Okay, thank you so much, Erin and Rebecca, for that awesome presentation. We are going to move on to Kelly and Nicole from Maryland now. All right, Kelly, take it away.
Thank you. Good afternoon. I'd like to give you a brief background on how our agency has worked and continues to work to address climate change and resiliency of our coastal ecosystems, particularly our coastal wetlands, and how we've bridged the gap from science to implementation and on-the-ground action through our land conservation policies and programs. So Maryland has long recognized the combination of sea level rise and land subsidence has made our coastline very vulnerable to coastal hazards and continued inundation. The Chesapeake Bay has already experienced a 1 foot rise in sea level over the last century, as well as a warming of over 2 degrees Fahrenheit. We're experiencing increasing storm surge inundation, particularly on the eastern shore of Maryland, which further jeopardizes the long-term viability of our coastal wetlands. The Maryland Commission on Climate Change's most recent sea level rise projections advise us to plan for a best estimate of 2.1 feet of sea level rise by 2050 and 3.7 feet of sea level rise by 2100. We're also expecting increasing variability in temperature, precipitation, and more extreme weather events. The Maryland Commission on Climate Change was formed by executive order in 2007 and has developed a succession of climate mitigation and adaptation plans over the past 10 years. Key recommendations that came out of these plans were to identify high priority protection areas and strategically and cost-effectively direct protection and restoration actions to preserve the key ecosystem services of wetland systems. Also, to develop and implement a package of appropriate regulations, financial incentives, and outreach and enforcement approaches to retain and expand forests and wetlands in areas suitable for long-term survival. And lastly, to promote and support sustainable shoreline and buffer area management practices. So in response, the Maryland Department of Natural Resources adopted a Building Resilience to Climate Change policy that spelled out specific actions to be taken through Program Open Space, which is our primary land conservation program. These actions were to identify landscape or site level characteristics that support ecosystem resilience, limitations on future use of the site, and opportunities to increase resiliency or mitigate adverse impacts, and also to assess land acquisitions for potential impacts of climate change and sea level rise. A little bit about Program Open Space. It utilizes a GIS-based targeting tool that incorporates natural resource data from across the Department of Natural Resources to identify those areas of the state that are considered ecologically the best of the best and are our highest priorities for conservation, whether through acquisition or conservation easement. So as you can see, this includes our green and blue infrastructures, our non-tidal fisheries, our wildlife and rare species habitats. And now under our DNR climate change policy, we've updated this tool to include our new priority wetland adaptation areas. So to integrate resilience considerations into our conservation targeting, we first removed those areas under 2 foot of elevation from the targeted ecological areas to avoid spending limited funds in areas that were expected to be inundated by 2050. Second, we wanted to include those areas that were important for habitat resilience to climate change. The highest priority for the state and for which we had the best available data were our coastal wetlands. So including these climate change priority areas really helps the state make long-term conservation plans with our future coastal conditions in mind. So the wetland adaptation areas, with the assistance of a NOAA Coastal Fellow, we looked at ways to identify those areas that, if conserved, could best facilitate landward movement of coastal wetlands subject to dislocation by sea level rise. The first step was to run SLAM for 2050 and 2100 sea level rise scenarios. And the second step was to target key habitat features, such as large contiguous wetland areas and those areas important to breeding marsh-dependent birds, while also prioritizing those areas that aligned with our state green and blue infrastructure assessments. The final outcome was a set of priority wetland adaptation areas. These were broken out into a range of low, medium, and high, with the medium and high range considered best of the best and therefore added into our targeted ecological areas. In addition, we utilize a threshold of 5 acres or more of wetland adaptation areas as a trigger for our coastal resilience conservation easements, which I'll speak a little more about. So a second insertion point for the data was our ecological scorecard. All properties considered for acquisition are run through an ecological scoring process, and they must meet a minimum threshold score to be acquired. So you can see under our habitat maintenance and restoration values section, that's step 3, we now give weight to the wetland adaptation areas in this scoring process. Lastly, we wanted to use the data to promote on-the-ground sustainable shoreline and buffer area management. This includes installing living shorelines or non-structural shore protection practices to deal with erosion, increasing vegetative or forested buffers where feasible, using erosion or elevation-based setbacks to site permanent structures, and designating and protecting wildlife habitat and wetland migration corridors. So as I mentioned previously, we removed those areas of the state that were under 2 feet of inundation from our targeted ecological areas, but in doing so we also removed areas of vital wetland habitat. To capture those properties that included low-lying wetlands as well as uplands suitable for migration, we utilized the coastal resilience conservation easement. The trigger for development of a coastal resilience easement is 5 acres or more of wetland adaptation area on the property. These easements differ from our traditional conservation easements in 5 ways. As you can see, they require development setbacks in areas subject to suitable rise by 2050. They provide buffers to protect these high-priority wetland adaptation areas. They impose stricter impervious surface limits to reduce runoff and pollution due to increased storm events. And they require grantee review, that's as DNR, of any new shoreline stabilization projects. And they also require mandatory updates of soil conservation and water quality plans every 10 years to ensure and promote best management practices. We have also developed an optional resilience action plan that a landowner can undertake to assist in a number of activities, including removal of barriers to wetland migration. So these plans look at wetland hydraulic restoration opportunities, potential living shoreline projects, invasive species management, environmental hazard management such as relocation of septic tanks, and adherence to our coastmark construction codes, removal of barriers to wetland migration such as impervious surface, and we work with the Maryland Historic Trust to document any vulnerable historic and cultural resources. In an effort to promote the use of this data, we've held workshops and trainings for our local and state partners on the use of the data, and we share it on our Coastal Atlas. This is a snapshot of the Coastal Atlas. It's a GIS-based mapping platform that's user-friendly. It doesn't actually require knowledge of ArcGIS, and it is available to the public. And so with that, my colleague Nicole Carlozo will talk about our coastal resiliency assessment that builds off of the work I presented that was highlighted in the case study.
Thanks, Kelly. Good afternoon. My name is Nicole Carlozo, and as Kelly just mentioned, I'll be talking about Maryland's Coastal Resiliency Assessment, which is another example of how the Maryland Department of Natural Resources is addressing resiliency through planning and tool development. And this effort also builds off of the wetland modeling and conservation targeting work that Kelly just shared. This tool was primarily developed to evaluate the risk reduction benefits of the state's existing natural features and to establish priority conservation and restoration areas where on-the-ground projects can enhance coastal communities that are impacted by coastal hazards, impacts such as flooding and erosion. So there were a number of factors that led to the development of Maryland's Coastal Resiliency Assessment. First, in 2012, Hurricane Sandy hit the U.S. East Coast. It made landfall, and while Maryland was not the hardest hit state in the region, we did estimate damages at more than $40 million. Following the storm event, federal funding sources became available to address coastal resiliency in the in the region through planning and also through on-the-ground restoration projects directed at vulnerable coastal communities. So an example of that is the NIFWIF Hurricane Sandy Competitive Grant Program. Regional analyses were also conducted to evaluate the vulnerability of coastal populations and to evaluate how natural features could reduce that vulnerability in the region. And an example of that I've listed here as the North Atlantic Coast Comprehensive Study, which was released in 2015. So at that time, at the Department of Natural Resources, we recognized that we didn't really have a mechanism to help identify protection or restoration projects where natural features would specifically be targeted to reduce risk for our vulnerable coastal communities. Then in 2014, the Chesapeake Bay Watershed Agreement was re-signed. Participating jurisdictions in this agreement from New York down to Virginia worked to support restoration of the Chesapeake Bay watershed to improve water quality and habitat. And new to the 2014 agreement was a climate resilience goal. And this goal called on participating jurisdictions to increase the resiliency of the Bay watershed, including its living resources, habitats, public infrastructure, and communities. So there wasn't only a focus on ecological resiliency, but also a focus on coastal community resiliency. And one means of meeting this goal is through the pursuit, design, and implementation of restoration and protection projects on the ground. So to address state needs and to address these regional goals, we initiated a coastal resiliency assessment in early 2015. Over the course of a year, we brought federal, state, and local nonprofit partners together to help us proactively identify, protect, and enhance coastal habitats to provide coastal protection benefits to Marylanders. And while all of the organizations and partners listed here were involved, we worked most closely with the Nature Conservancy over a one-year time frame to develop the assessment methodologies and the data products. And the Nature Conservancy has been very helpful also in communicating the results of this effort to our partners. We drew on previously developed methodologies, both from the U.S. Army Corps of Engineers and from the Natural Capital Project, and we modified those analyses and models for application at a state scale. I wanted to mention that all of the organizations and agencies listed here were part of a steering committee that met quarterly over the course of the year, and we wanted to include as many partners as possible to ensure that the products of this assessment were usable by as many state partners as possible. Beyond this group, we also reached out to almost 30 experts in the region to help inform the model inputs and methodologies. So one of the first decisions that our steering committee made was to define the term resiliency for this project. And this was used to help guide the methodology and modeling decisions throughout the assessment. And we defined resiliency as the ability of a community to prepare for, respond to, or recover from a coastal hazard event. To evaluate resiliency, we asked 3 questions. First, where are the people located, and are there demographic or social metrics that indicate how resilient a community might be in the face of a hazard or emergency? Second, where are the hazards or areas that are more prone to flooding and erosion? And third, where are the habitats or the natural features that buffer coastal communities and provide risk reduction benefits? So to answer these questions, we drew on a number of models and methodologies that had been developed previously. To answer the first question, we drew on the U.S. Army Corps of Engineers North Atlantic Coast Comprehensive Study, and through that study, they completed a risk analysis. To answer the last 2 questions, we drew on a model developed by the Natural Capital Project called the Invest Coastal Vulnerability Model that allowed us to evaluate coastal exposure along Maryland's shoreline. And as I mentioned, both of these models were adapted for use at a state scale. And I'm not going to spend time today talking about the details of these models, but feel free to contact me or search online if you'd like more information about them specifically. So when using the term natural features for this project, or coastal features, we are referring to coastal habitats that provide risk reduction benefits, such as wave attenuation, shoreline stabilization, and infiltration. For this project, we considered a number of natural features, including coastal forests, tidal wetlands and marshes, oyster reefs, submerged aquatic vegetation, and dunes along Maryland's shoreline. And the benefits of these features have been well documented in the scientific literature and by local experts, and we drew on that knowledge and information to help us inform our model inputs and methodologies. And this is a diagram from an U.S. Army Corps report that came out in 2015 that I think does a pretty good job of capturing the different benefits that these features provide for nearby coastal communities. So in Maryland, we have 16 coastal counties along with Baltimore City that are part of our coastal zone. And the study area for this project was defined as the furthest extent of a flood hazard event within that coastal zone. So spatially, this was translated and defined as the storm surge extent for a Category 4 hurricane as depicted by NOAA's SLOSH model. And this study area was really helpful for us because it helped narrow our focus to natural features that buffer impacts from coastal storms. So we really focused on areas at the land-water interface for this study. Riverine and upland flooding were actually beyond the scope of this study, so any precipitation-induced flooding and those types of factors were not considered in this analysis. So next I'm just going to walk through some of the data products that came out of the assessment and the different models that we ran. We produced a number of products that are available on Maryland's Coastal Atlas, which is the online mapping platform that Kelly mentioned. The first data product I'd like to talk about is our community flood risk areas. And these are residential areas that we think may be less equipped to prepare for, respond to, or recover from coastal hazard events. Residential areas were ranked from low to high risk based on 3 different factors: population density, social vulnerability, and probability of exposure to a flood event. And those are depicted in these panels at the bottom of the screen. For population density, we calculated that for residential areas using the U.S. Census Bureau data. We also utilized a bathymetric mapping toolbox from USGS to focus on only residential areas and to calculate that population density within those areas. Social vulnerability was ranked based on 3 different metrics. We looked at the metrics of age, income, and language proficiency, and we tried to select social metrics that we think represent the ability of a community to prepare for, respond to, or recover from a coastal hazard event. And we wanted to select metrics as well that relate to factors like mobility, communication, and resource availability in the event of a hazard or emergency. So we looked at age, income, and language proficiency for that. And then lastly, probability of exposure to a flood event was determined based on effective FEMA floodplain data. And at the time of the analysis, we worked with Maryland Environmental Service and Dewberry to obtain stillwater elevation data and FEMA floodplain data for this piece of the analysis. And we combined all of these factors together to create our community flood risk areas, which is shown on the far right with high risk areas in red and low risk areas in blue. And it's difficult to see on this slide, but if you visit our online mapper, you can zoom in to different regions of the state and get a better idea of the different rankings and why those areas were ranked the way they were ranked. Along with evaluating community risk, we also evaluated coastal exposure and the role that habitats play in reducing that exposure. So we utilized the INVEST Coastal Vulnerability Model, and that model is run at a 250-meter scale, and we produced 2 major data layers with that model. First, on the left, we have our Shoreline Hazard Index, which ranks relative exposure along Maryland's shoreline, and this is based on a number of physical parameters and shoreline characteristics, which are listed here. We looked at shoreline type or sediment type, elevation, relative sea level rise into the year 2100, wave power, storm surge height for a Category 2 event, and also historic erosion rates. And so all these factors were considered to rank each shoreline segment as low hazard, which is shown in blue, moderate hazard, which is shown in yellow, or high hazard, which is shown in red. We also evaluated the relative role that habitats play in reducing coastal exposure by acting as a buffer against coastal hazard impacts like flooding and erosion. So I also wanted to mention that all of these factors that we looked at here all relate to either the propensity of the shoreline to erode or to risk of inundation. So the role that these types of habitats play in reducing risk will depend on the types of habitats present. So the model takes into account that a shoreline with a coastal forest or a wetland will have greater protection than a shoreline that only has SAV or oyster reefs. The model also considers the fact that multiple habitats that occur together or in concert with each other will provide more protection than any one habitat that occurs alone along the shoreline. So this layer identifies shorelines where habitats play a high role in risk reduction in dark green. Habitats that play a low role in risk reduction are shown in orange, and shorelines where habitat plays no role in risk reduction, those are shown in gray. And those mostly occurred in our more developed areas where coastal habitat may not exist and the shoreline is hardened, or where coastal habitat is very minimal. So these are areas like Baltimore and Annapolis. So all of these data layers were then compared and combined together to identify our priority shoreline areas for conservation and restoration actions. Our Tier 1 shorelines are shown in orange on this slide, and these are our high priority shorelines where we think habitat plays a high role in risk reduction, and they represent about 22% of Maryland's coastline. And these are areas where we want to work to conserve what already exists, to maintain and to enhance existing coastal features. Our Tier 2 shorelines are the moderate priority shorelines, and those are shown in brown. And these are areas where we think habitat plays a moderate role in reducing risk, and they represent about 40% of Maryland's shoreline. And these are areas that we want to investigate restoration opportunities to see if expanding existing habitats or restoring habitats along those shorelines can help further reduce risk for nearby communities. And for all of these different priorities, I wanted to mention that all of these shorelines must fall at least 2 kilometers from a community flood risk area. This screenshot here is from our Coastal Atlas mapping platform, and when you zoom into the data, you can see that it's really represented by a point shapefile. Every 250 meters along the shoreline, there's a point with more information about that shoreline. And when you click on that shoreline point, it provides information about the type of hazards for that area and how the shoreline ranks for those hazards, as well as the type of habitats that are present. So you could find out more information by clicking on that point and viewing the pop-up box within our atlas. So one limitation of the shoreline analysis and the INVEST model is that it really only provided data at the land-water interface. But we at the Department of Natural Resources did recognize that communities exist further inland that are still at risk of flooding. And many of our coastal habitats also do extend inland and provide some type of risk reduction benefit and protection benefits for those communities. So we decided to take a closer look at one of our coastal habitats. And because Maryland marshes are one of the more protective and extensive habitats, we decided to delve a little deeper and look at Maryland's marsh complexes. The Nature Conservancy had previously developed a marsh protection potential index for other coastal states. So we modified that approach for Maryland and developed a marsh protection potential index, which ranks marshes based on their ability to protect people from coastal hazards. So this index really ranks these marsh complexes based on 5 different metrics. We looked at marsh size, the proximity of the marsh to a high hazard shoreline or to a floodplain, the proximity of a marsh to a very dense or socially vulnerable population. We also looked at the proximity to other protective habitats. So if a marsh was adjacent to an oyster reef or a coastal forest, it was given a higher protection ranking than any marsh that occurred alone within the landscape. And then lastly, we also introduced a persistence factor. So we looked at how the marsh was expected to persist into the year 2100 with marsh migration potential and sea level rise risk. And so through this factor, we were able to pull in the marsh migration corridor data that came out of the SLAM model that Kelly talked about, and rank marshes based on their potential ability to migrate and persist even with sea level rise. And so each marsh was given a score from 1 to 25 that corresponds to a ranking with very highly protective marshes ranked in blue and low protective marshes ranked in red. And we can use this information alongside our shoreline data sets to help inform our restoration and conservation targeting, as well as our management of these marsh complexes. So last, I just want to talk a little bit about how we're working to integrate the data and the results into our programs at the Department of Natural Resources. As Kelly mentioned, we have our land acquisition program, and within that program, we have our program Open Space, which utilizes a Greenprint ecological scorecard to score parcels for acquisition. And we're working this year to update that scorecard and to include our Tier 1 priority shorelines and our marsh index within that scorecard so that we can elevate the score of parcels that occur within our priority areas for resiliency projects. We're also exploring how to combine this information together with our marsh migration corridors and the result of the SLAM modeling to help better identify opportunities for resilience easements. In addition to our work at the Department of Natural Resources and for our conservation efforts, we're also working with a newly formed State Resiliency Partnership to leverage state resources and expertise towards implementation of projects within our priority areas. And this group work together. This is a group of a number of state agencies that work together to help pull together the State Hazard Mitigation Plan update, which was released in late 2016. And we were also able to have a representative from the Maryland Emergency Management Agency on the steering committee for the Coastal Resiliency Assessment. So because of that collaboration, we were able to include our priority areas within the State Hazard Mitigation Plan. So as funding becomes available to help implement these strategies, we may be able to get some funding for on-the-ground projects. And so the State Resiliency Partnership is really helping to facilitate the implementation of the strategies outlined in the Hazard Mitigation Plan. And then lastly, from a restoration standpoint, we are working internally to identify projects within our priority areas and adjacent to the community flood risk areas. We're also working to ground truth some of this information and assess really how this statewide data translates to work at the parcel scale because this information really was developed for use at a statewide scale. We're also pursuing funding to conduct marsh health rapid assessments and also to monitor for wave attenuation and flood reduction benefits to inform management of some of our marsh complexes that we think are doing the most to protect coastal communities and to determine what the appropriate interventions might be moving forward with sea level rise and as climate change impacts these habitats. So if you're interested in learning more about the data or the methods, you can visit our website. We have access to a training manual. We held a training, two trainings last year when we released this data, and we're working to hold 2 more trainings over the next year, so that will most likely be updated sometime soon. We have links here for our Coastal Atlas mapping platform, and if you are able to download the training manual, it'll show you how to access, analyze, and download the data from our Coastal Atlas. We have links to our Coastal Resiliency Assessment web page and our Climate Change and Coastal Conservation page. And if you're really interested, we have some Esri story maps available on our website that kind of walk the public through how we utilize this information in state decision making. So thank you.
Great. Thank you both to Nicole and Kelly on another excellent presentation. Our first question is 2 parts. Do you educate the public on how wetlands can help reduce community exposure and mitigate hazards and extreme events? And how do you educate communities on their specific risks?
So I can answer part of it, and then Kelly, you can add in. We have a coastal training program that's available through our Coastal Zone Management Program here at DNR. So we have trainers that work with local communities to do just that. They also offer trainings for staff to help us better communicate when we're out in the field and talking to community members. it's really just a networking process, and as you reach out to your local partners, you're introduced to other local partners, and just through kind of informal dialogue, communicating to them and helping them to communicate to the general public about these issues.
That's awesome. So our next question is, are localities taking action to reduce risk as a result of the info Maryland provides?
Yes, one thing we didn't cover here is that we do have a CoSmart Communities program that is also run out of our coastal zone management program, and we offer grants and technical assistance to local communities to plan for coastal hazards and flooding, and we have had many years of grants that have gone out that have been very successful in assisting local communities for this type of planning.
That's great. Thank you both so much. I think we are going to turn it over now to Carrie Banks from Massachusetts.
Good afternoon. I'm Carrie Banks. I'm with the Division of Ecological Restoration in the Massachusetts Department of Fish and Game. And I'm going to be talking about how the Massachusetts River Continuity Partnership is working to maintain stream connections with fish-friendly and flood-resilient infrastructure. So as we're all aware, aquatic connectivity, what we often refer to is as stream continuity, it's critical for maintaining long-term ecosystem health and stream processes, especially given that our stream systems are long linear systems. Man-made barriers like the dam here can often lead to ecosystem fragmentation, decreased organism mobility, and disruption of key ecosystem processes, such as the disruption of sediment and debris transport. So when our program began thinking about disruption to stream continuity, we focused in on dams back in around 2000. In Massachusetts, we have over 3,000 dams. And we began our first dam removal in 2000. And since then, we've removed over 58 dams here in Massachusetts. This has been both by my division and our project partners, but as well as independently by municipal and private dam owners. And I think that municipal and private dam owners in particular are becoming interested in dam removal because it's becoming a viable and cost-effective option. The pace of our dam removals have increased over the years. In fact, in 2016 alone, we initiated construction or completed construction on 12 dam removal projects here in Massachusetts. Some of the key strides in our dam removal program, I think, were the result of an update to our dam safety laws, which happened in 2005. This was following the threat of an imminent dam failure in the city of Taunton, and that nexus with public safety really built the momentum to consider dam removal as an option with our aging dam infrastructure. Our program was also instrumental in providing technical and outreach guidance that were targeted to our state and local permitting agencies, as well as consultants and dam owners. And we also had, now that the program's been around for the last 15 years, we have results to share documenting the benefits from these dam removals. We've also increased funding support. The state of Massachusetts has initiated a dam and seawall repair and removal program. In 2016, allocated $10 million in grants and low-interest loans to communities to either repair dams that provide a significant public interest, such as water supply, or remove dams that are creating public hazards. So around the same time that our dam removal program was getting off the ground, we began to wonder about some of the other man-made barriers that we had on our landscape. And when we looked at our road stream crossings, we had over 30,000 here in Massachusetts. So it seemed like a good place to really further assess and determine where we had aquatic barriers. So we formed the Massachusetts River Continuity Partnership in collaboration with the Nature Conservancy, American Rivers, and the UMass Amherst Extension. So since then, we are now, we've expanded into a multi-agency organizational effort to promote fish and wildlife passage at road stream crossings here in Massachusetts. Partnership now includes representatives from our Department of Environmental Protection, our Department of Transportation, our Divisions of Fisheries and Wildlife, and our UMass Transportation Center, as well as nonprofit conservation organizations like Mass Audubon and federal agencies such as the U.S. Fish and Wildlife Service. We will also work with on-the-ground partners. So, for example, we work with our watershed associations and groups like Trout Unlimited to conduct assessments of our road stream crossings. And we're also working with our regional planning agencies, particularly when they're working on their transportation improvement plans or hazard mitigation plans with the local communities. Inspired by the work that we've been doing here in Massachusetts, states like Maine, New Hampshire, Vermont, Rhode Island began implementing their own stream continuity programs. And in 2015, with funds from the North Atlantic Landscape Conservation Cooperative and the U.S. Fish and Wildlife Service, practitioners from around the region formed a 13-state collaborative, now known as the North Atlantic Aquatic Connectivity Collaborative, to address aquatic connectivity on a regional scale. Thus far, the collaborative has created a network of expert professionals, including staff from state and federal agencies, fisheries and wildlife biologists, transportation officials, and regional nonprofit conservation organizations. And since each state had to slightly do things a little bit differently with their methodologies and approaches, one of the first projects that the collaborative worked on was developing a unified assessment protocol for road stream crossing assessments that were intended to identify where problems were occurring for aquatic passage. And then created the infrastructure to support the collection of this data throughout the region. So the collaborative also provided the framework that we needed to implement these assessments, as well as the data forms, instructions, and training materials for the unified field assessment protocol. Responsibilities are split up into 4 tiers. We have our field surveyors, as pictured here, who go out and actually collect the road stream crossing data. They are certified or they're trained and certified in the assessment protocols. Trainings include an online training module, as well as a full-day field training, and then shadowing other certified surveyors in the field for at least 20 sites. We have our local coordinators who coordinate surveys, usually at a town-wide or a watershed-wide scale. And then we have state and regional coordinators like myself who coordinate assessments across the broader region. And then we have our database and system management coordinators that work on maintaining the database where these records are actually uploaded. So after a volunteer goes out and collects a variety of information on each of these road crossing assessments, they upload that data into this database, and each crossing is assigned an aquatic passability score, and that'll rank the barriers accordingly. So in Massachusetts, where we've conducted road stream crossing assessments, we have found that over 44% of our road stream crossings create moderate to severe barriers to aquatic passage. This is pretty consistent with the comprehensive surveys that have been done here throughout the Northeast, which typically finds between 40 and 60% of road stream crossings creating moderate to severe barriers. When we look more closely at the data, what we find is that about 95% of our bridges rank as providing full passage, or primarily they only create insignificant barriers. So our bridges are doing pretty well in providing particularly aquatic passage and sometimes wildlife passage at those locations. However, if we look at our closed bottom structures, or often things like corrugated metal culvert or a plastic pipe or a concrete box culvert, those moderate to severe barriers increase to 61%. And if we consider our minor barriers, which are basically a crossing that creates a barrier under certain conditions, for example, low flows or high flows, then 95% of our culverts are creating some type of barrier to aquatic passage. And none of those culverts are providing full passage for aquatic and semi-aquatic species. So here are some of the culverts that I'm talking about that represent some of these moderate to severe barriers. As you can see through these photos, some of the common problems, and actually the #1 barrier that we find at these crossings, is outlet drops. And that's depicted particularly well in the middle photo at the top. A lot of these crossings don't have natural substrates within the crossing itself, and they can also create velocity and or flow depth barriers. That's particularly evident in the middle right-hand side with the concrete box culvert. You can imagine at low flows that would be very hard for an aquatic organism to pass through. Inlet drops can also be caused, especially where crossings disrupt the sediment transport. In the middle photo, on the lower part here, you can see that the deposition of sediment is occurring behind the crossing, and it's actually creating a drop into the crossing. And sometimes other physical barriers can be found associated with these crossings that might include things like fencing, deformation of the culvert itself, other free falls other than the outlet drop that are associated with the crossing, and again, sediment and debris blockages. So the data that has been generated by primarily our volunteers, citizen volunteers, has been put to use in many different ways. And I think the most valuable benefits have been building partnerships at both the local and regional scale, but especially when we're communicating with our highway officials. We've also generated numerous case studies that document, for instance, repetitive failures, so crossings that have washed out on a repetitive basis, as well as how both a traditional culvert, like the ones I pictured before, and upgraded crossings perform over time. But I think one of the other benefits has been is really providing us a comprehensive picture of the problem. We're realizing that this is not just a local issue, but it's a regional landscape scale issue. For these reasons, the collaborative continues to work on collecting data and expanding our assessment methodologies. We're currently working on additional modules that include looking at culvert condition. That will be implemented this field season. And this is particularly of interest for transportation officials, knowing where infrastructure maybe need to be upgraded and might be providing us opportunities to gain both the transportation benefit and an ecological benefit. We're also looking at risk of failure of these crossings, particularly during flood events. And the current assessment methodology is intended only for freshwater inland crossings. And so this field season, we're going to be testing a tidal assessment that will be looking at tidally influenced crossings. And we're also incorporating a terrestrial passability assessment methodology into the assessments of these crossings. So I wanted to mention a couple of the tools that have spurred from these efforts. The first one is that the collaborative created a prioritization of our HUC 12 subwatersheds in this 13-state region. And what's nice about it is that it includes a customizable tool extension for ArcGIS, which allows the user to rank the weight of the metrics that were used. So you can rank the metrics based on your interest. So for example, if you're more interested in migratory fish, or you're more interested in resident species, you'll be able to rank the metrics accordingly and reprioritize the HUC 12 basins. This is especially helpful if you're interested in looking at a watershed-based restoration approach. The Northeast Aquatic Barrier Prioritization Tool was developed originally by the Nature Conservancy, and at the time it was originally developed, it was mostly focused on dams, but has now been updated to include the culvert assessments that have been collected in the 13-state region. And its purpose is to support planners and managers in targeting dam removals and fish passage improvements that maximize the ecological benefits. And what's also nice about this tool is that it does allow a user to run dam removal and culvert replacement scenarios to determine which projects would give you the maximum benefits. The other tool that I wanted to mention is the Stream Crosser Explorer tool. This is being funded by our Department of Transportation in response to some of the damages sustained during Tropical Storm Irene. And it's being piloted in the Deerfield River watershed, which received the most significant damage. This tool is going to be looking at not only the aquatic connectivity and ecological aspects of the rivers, but also the risk of failure of road stream crossings and the associated disruption of emergency services. There is some interest in applying this tool region-wide, but we will have to wait and see on funding for that. So through the collection of these numerous case studies, we have found that traditional culverts are not only resulting in disruption of fish migration, we're also finding that they're vulnerable to failure. In fact, the photo on the lower left-hand corner here is one of our case studies where this crossing has repetitively failed. It would fail twice in less than 6 years and just was recently replaced with a large open bottom arch structure that was funded by our Massachusetts Emergency Management Agency through a hazard mitigation grant. So these traditional culverts often, are vulnerable to failure, and one of the reasons primarily is because they do accumulate debris, which even if they don't fail, they end up costing more in maintenance. And when they do fail, the repairs often are very costly because they're done under emergency repairs and replacements, and there's usually extensive road damage that are associated with the failures. And this ultimately has impacts the stream habitat, particularly downstream where sediment is being deposited either within the channel or within the floodplain. Also, using some of the data that we've collected, there's been several cost-benefit analyses that have been documenting the economic and ecological benefits of better designed crossings, like this one, the study conducted by the Forest Service. While it's clear that the upfront costs of these structures are higher because they do increase in size compared to the traditional culverts, the long-term savings can be achieved by reducing that risk of failure, reducing the need for the periodic maintenance, as well as increasing the lifespan of the structure itself. And in some cases can reduce the cost of mitigation for open water and wetland impacts. This is particularly important in light of changes in the intensity and frequency of precipitation events that we've been experiencing here in the Northeast. It makes culverts a really critical issue for both natural resource conservation managers as well as for public safety and infrastructure. So around 2005, once we identified that road stream crossings really presented a landscape scale problem, the partnership worked on developing new performance standards for road stream crossings here in Massachusetts. And the goal of the standards was to facilitate fish and wildlife passage and the continuity of river and stream corridors. They're not intended to replace structural or hydraulic engineering and design standards. So again, they're really focused on looking at the movement of fish and wildlife. So some of the key ingredients of the standards included looking at spans that were greater than 1.2 times bankfull width. We prefer having a bridge or open bottom structure. As I referenced looking at the data previously, our open bottom structures tend to perform the best in maintaining aquatic continuity. We also want to see natural substrates through the crossing, as well as having comparable depths and velocities compared to the natural stream segments. And where possible, providing dry passage, such as banks, for semi-aquatic or terrestrial passage. The partnership not only provided technical standards, but we also provided some guidance materials, such as our Massachusetts Stream Crossing Handbook, which will be available on the website that I'll have at the end of my slideshow. So in 2005, the Army Corps of Engineers adopted the stream crossing standards into their programmatic general permit under the authority that's delegated to them through the Section 4 of the Clean Water Act. So basically, for the discharge of dredge and fill material. And in 2008, our Mass Department of Environmental Protection amended our 401 water quality certificate regulations to require that new crossings meet the stream crossing standards. And in 2014, the stream crossing standards were formally adopted into our Massachusetts Wetlands Protection Act. And they now are required for all new crossings, and any crossing replacement must meet the standards to the maximum extent practicable. And what that means is that the applicant needs to consider the environmental benefit of meeting the standard compared to the cost by evaluating a list of 12 criteria. And I'd be happy to provide those if anybody's interested. So ultimately what we're looking for is a crossing that looks something like this. Basically that we have an uninterrupted stream and continuous stream, and it's providing multiple pathways for a variety of aquatic organisms. despite having these regulatory requirements and knowing that we're experiencing an increase in severe storm frequencies, as well as knowing the impacts of our undersized crossings to both aquatic organisms and public safety, we're seeing few culverts that are being completed that meet the stream crossing standards. And it's not that our communities don't intend to meet the standards. What we think is what's happening is there's some type of disconnect between awareness and implementation, as well as just some of the logistics of actually implementing these types of projects. So for example, this right-hand photo here, if you look closely, you'll see that this is actually a concrete open bottom box on the bottom here that's been flipped over and a concrete slab has been put on top. And this is because when the community went to go put in this open bottom concrete box or three-sided box culvert, they ended up finding utilities buried at a depth that wouldn't allow them to place the structure at the elevation that was needed to maintain the stream continuity of the channel and the elevation of the channel. So using our Yankee ingenuity, they flipped that box culvert over and found another way to reopen the road. So the reason we know that communities are having difficulty in meeting our standards is because we're picking these up in the assessments. And this is an example of a location that we go out to anytime we update our assessment protocols. We will go out to a handful of crossings to reassess them. And this is one of these locations that we assessed in 2008. And you can see in 2008 we had a corrugated metal culvert, 5-foot metal culvert. And when we went back in 2015, we had a smooth pipe, 5-foot plastic pipe, which actually was elevated slightly higher above the stream bed. So we actually had a slightly higher outlet drop. And what's nice about this is that the plastic pipes nowadays actually have the manufacture date stamped on the crossings. And this one was manufactured in 2013. So we believe this crossing likely either washed out or was damaged during localized intense precipitation events that happened in the summer of 2013. And you can see from the photo on the top here where we're looking at the inlet that this existing crossing now that is there continues to have problems. You can see that there's road fill being lost. And right before this photo was taken, you can actually see there's some debris here that the volunteers had moved out of the way so that they could get the measurements. So this is continuing to have problems and is still vulnerable to failure and potentially sending more of that road fill downstream. So in Massachusetts, we have over 30,000 road stream crossings that are mostly town-owned and maintained. And we really felt like we needed to work with our communities to identify what the barriers are to implementing these stream crossing standards. So in 2014, our division hired a full-time staff person to develop our program and to increase the statewide capacity to implement culvert replacements. And one of the first things that he did was he conducted a strategic statewide needs assessment to identify the barriers to implementation. From that needs assessment, we had a pretty good response rate. We had 37% of our DPW statewide providing feedback about their operations and the barriers they faced. From that needs assessment, it was revealed that municipalities face barriers at all steps of culvert replacement process. That includes the lack of in-house expertise for design of culverts, the inability to identify which culverts are most vulnerable to washouts, and of course our number one was a lack of funds for engineering, design, and construction, as well as difficulty with the permitting process. And that was both with the environmental as well as our transportation permit reviews. So in Massachusetts, any project that has a span greater than 10 feet, or between 10 and 20 feet in particular, they have to go through a state engineering review with our Department of Transportation. And so that was a barrier, as well as some of the environmental permitting. So what is my division doing about this? Well, we now have 1.5 full-time equivalent staff that are working on supporting assessment work, as well as providing that direct technical assistance and outreach with our highway departments across the state. We're also establishing 6 long-term training sites where DER, or my division, is helping fund and assist the town from beginning to end on the project. And we're hoping to gain from these long-term training sites opportunities to develop trainings in modules, as well as tools to make culvert replacements easier, more efficient, and cost-effective for the municipalities. And as we know that the upfront costs in meeting the stream crossing standards are higher, we're hoping to launch our culvert replacement municipal assistance grant program, which is going to assist towns to replace more road stream crossings. So pending funding approval, we're hoping to have $750,000 annually over the next 4 years. And we'll probably be granting grants in the range of $25,000 up to $200,000 per year. The projects can be in any phase of replacement as long as they're meeting the stream crossing standards to the maximum extent practicable. So that could include the early phases where they're beginning field data collection through design and permitting, as well as construction. The other thing I think our division always emphasizes is the value of our partnerships. And in the STRIDE, we're continuing to work with the Massachusetts River Continuity Partnership as well as the Northeast Aquatic Connectivity Collaborative to support cost-effective, flood-resilient, fish-friendly road crossing designs. So with that, I wanted to point out here, this is some of our websites that I referenced before. You can find a copy of our stream crossing handbook as well as a host of other resources at our website, which is massgov/DER. The other go-to website is the North Atlantic Aquatic Connectivity Collaborative website, which is streamcontinuity.org. On that site in particular, I think you might find useful is a climate-friendly stream crossing toolkit. The toolkit offers a variety of educational and informational materials, tools, and resources that have been compiled by the 13-state collaborative. I'd be happy to take any questions.
Thank you, Carrie, for another excellent presentation. So we have a few questions for you before we'll move on to questions for all the panelists. There seem to be many moving pieces. How did you effectively build collaborative capacity with the many players, and is this something that you must consistently work at?
Yeah, I think one of the most effective ways in communicating with the folks that have probably the biggest impact, and that's our highway departments and our towns, was tying it into the public safety and infrastructure aspects of the work that they're doing. We held a series of trainings following Tropical Storm Irene with our municipalities. We initially were going to only hold 3, and they were so well received that we ended up holding an additional 3 across the state. So I think, you know, tying things back to the public safety and infrastructure perspective has really helped us be able to message and encourage people to be thinking about these issues. Often when I'm meeting with a highway department personnel, I'm not talking about fish, which is usually my primary concern, but we are talking about, you know, how is that structure going to perform over time? What can they expect in the next extreme precipitation event? Things to be aware of, especially if they're approaching a project. So I think that really has been what we've been focusing on and how we communicate with people. In regards to increasing the partnership, through that, I think that has opened up avenues to work with a variety of professionals that are thinking about these things, both from a transportation as well as a fisheries and wildlife perspective. So we try to continue to build those partnerships wherever we can.
Great. That's a great segue to our next question. Do you consider climate change predictions when designing new culverts and stream crossings? And if so, what is the time frame?
That's a good question. So I mentioned our Stream Crossing Explorer tool that's being developed for the Deerfield. That was looking at a variety of storm events. I don't remember exactly off the top of my head, but it was predicting out, you know, for future climatic events. And we definitely think about it and talk about it. When we develop the standards, we could have gone, if you look at the other state standards, sometimes they range from, you know, having spans that range from bank full width to 1.5 times bank full width. One of the reasons why we ended up at 1.2 times bank full width was to accommodate for some of those considerations and changes that we might see within our stream corridors.
Great. Thank you so much, Carrie. Our next question is for Aaron. Is there a specific database or platform you use to collect and analyze your data?
For harmful algae bloom monitoring data, if we collected it here at our organization DEQ, it goes into our laboratory information management system, and we're now integrating into a new external database that's connected to Storette. If it's external data partners, we really don't capture that information unless they submit it somehow to the water quality portal. As far as advisory information, that's housed at the Oregon Health Authority.
Great. Thank you, Aaron. Our next question is for Nicole and Kelly. Is there good cooperation with adjacent state agencies to build and act on findings?
Yeah, so we work with a number of state agencies, specifically with our conservation programs. We've been working with the Maryland Environmental Trust and the Department of Agriculture as well. They have an easement program for rural lands. We work quite a bit with a number of our local land trusts and local municipal and county governments as well.
Yeah, and for some of the restoration targeting work, like I mentioned, we're really working with the hazard mitigation community for that, working with Maryland Department of Planning, Maryland Department of Environment, and Maryland Emergency Management Agency through the newly established State Resiliency Partnership. So that's something that we've been working with these different folks kind of informally over the years, and we're just starting to kind of come together a little bit more formally to exchange ideas, resources, and expertise kind of in a more formal platform.
Great. Thank you both. Our last question, unless there are more for the panelists, feel free to use the chat box, is for Carrie. Have there been any considerations for how increasing aquatic connectivity may allow for additional penetration of invasive species into new areas?
Yes, there actually, we don't have that issue as much here in Massachusetts, but I know other states, I believe like Wisconsin, out of the Great Lakes, they will often maintain the first barrier to prevent the intrusion of invasive species into the system. But that is a consideration I know several other states have taken into account in the work that they're doing.
Great. Thank you so much, Carrie. I'm going to hand it back now to Stephanie Santel for some closing remarks.
Well, first of all, I am going to actually put it back to our amazing presenters today if they want to, starting in the order that we went with, Oregon, Maryland, and then Massachusetts, if you all want to provide some closing remarks and maybe things to remember for the audience members as takeaways. So I'll turn it over to Aaron first.
Well, I think a common thread through all of our presentations was the importance of collaboration, and I think particularly in an environment where resources are very limited, that becomes increasingly relevant to being able to respond to particular situations like harmful algae blooms. I know it works sufficiently here in Oregon, and we're continually trying to improve that process and develop partnerships so we can better respond to blooms when they crop up.
Okay, Nicole and Kelly.
Sure. So I know we presented quite a bit of the technical data and modeling work that we've done here. I just wanted to reiterate that we are happy to provide some of the additional details and technical reports to anybody that may be interested in utilizing this in their own communities and their own states.
All right, and finally, I will leave the closing remarks from our presenters from the states with Carrie.
Well, I guess I would encourage everybody to go to the EPA website and pull up our state practices. I know Stephanie worked really hard to get a lot of information into 3 pages, but there's a lot of great web links there as well to a lot of things I didn't get to mention in this presentation. So if you get that opportunity, I encourage you to do that. And I would reiterate the partnerships. I think that's really key in moving forward. but as well as not losing the message that people are part of this picture. One of my other slideshows that I often give, I compare our stream corridors to our road corridors and how they're both intended to move people and or fish and goods and materials, or stream bed sediments, for example. And so I try to really show that this is, something that we should all be thinking about, no matter what perspective you're coming from.
Thanks, Carrie, and thanks, everybody. And special thanks for that shout out. I appreciate it. Again, a huge thanks to our state speakers today. It's been very fun to work with all of you, and their work has been inspiring to me personally, and I'm always very excited to share it with everybody. Thanks again to our project partners and the state associations we work with for their continued support, and to ICRA for moderating questions today. And thanks to everybody who's sitting in the room with me for helping out with putting this webinar together. It definitely wouldn't have come off without a hitch without you all. And then finally, thank you to our audience for taking the time to join us. We really appreciate it. And again, feel free to contact us if you have questions or want more information. Thank you so much.